For students that can able to use their audio, maybe in quiet zone, feel free to use chat. But we encourage you can discuss with the other student in this session. As Chris already announced in LMS, we have 2 sessions for tutorial in hydraulic unit. Tuesday with me and Thursday you will have the tutorial session with Chris. Actually, we discuss the same problem. Each module you already see Liang upload some problems for you to exercise. But please note that in week 6 and week 10, when you have a test on Friday, in Thursday session, the tutorial will review the module in, so you need to prepare for the test. So I'm encourage you to attend this session as well. So for today's session, we will discuss 4 problems. So starting from problem 1 until problem 4 in module 1. And this is the activity for today's tutorial. So after this, I will break up you into rooms. I think we will directly break up into 4 rooms. And each room, student will work in their own paper for solution in problem 1. So it means that room 1 will try to exercise or to try to find the solution for problem 1. Okay, and then at the end of the session, in the break room session, please choose one speaker that will present the solution. I will attend your room. Each room I will try to attend, so I can give you some assist. If you want to ask a specific question, at the end of the session, we will have still remaining time. You will ask, maybe you want to ask a problem or in recording that you found, just feel free to ask. You can also raise your hand and use the chat feature to ask the question. Any question? Yeah, if no question, okay. Before we break a room, let's see our question. I already, you already see in the screen that for the problem 1, you have a tank. And then for the problem 2, you also have a tank, and you can use like the conservation mass or conservation momentum to solve this kind of problem. In this tutorial, we hope you can solve step by step of each problem until you find the final question that already provided in this session. For example, this one. Okay, what do you think? I need your feedback. So we discuss one by one for the question first before I break into a room, or you will directly want to discuss in the room. Okay. I thought we were doing the first question. Sorry. Okay. So guys, sorry for CNET. It's thought there you are guys doing the first question. So wait a minute. When you join the breakout room, which room that you join? breakout room number 3, right? Yes, exactly 3. Okay, okay. Everyone in this group discuss the problem number 3. Okay. I will try to share again the problem number 3. Yep, this one, right? Oil with density. First, without doing any calculation, explain whether the net vertical force on the fluid in the control volume will be upward, downward, or zero. So we know that in this net vertical force, it means that in this case, the 1 centimeter, maximum is 1 centimeter. So the velocity profile in this equation is different along the air, along the radius, but it's similar along the pipe. That's why they stated that the velocity profile is everywhere along the pipe, but will be different if the air small. Yes, it's different like this. Can you get it?
The R small. No, sorry. Like I don't get what R small is. The small R.
It's same with this. For example, if you have the x direction along the coordinate Cartesian, right?
Yes.
And then you work in this from small x in the x1, x2, x3 example.
Yeah.
So yes, the UR in this case, it will be different in this area because you have the U max.
Okay.
So 1 minus R what? R will be different along the radius because this is maybe the R1, R2 until the maximum is the capital R, just 1 centimeter.
All right, so I think I get it. So basically, it's like the small r is anywhere.
Yes, exactly.
Here.
Yeah, okay. Until the R maximum of R.
Yeah. Oh, all right. Thank you so much.
Yep.
And also about the pressure, force of pressure. I don't know like where I went wrong, but I end up getting 2.8274. 2.8274.
874. Oh, yeah. Maybe, but you already get the same pressure, right? 9,000 Pascal.
Yeah, 9,000 Pascal.
Okay, 9,000. Okay, maybe I mistake into the calculation. I will directly calculate right now. 9,000.3.14. 0.01.
I mean, I put 0.01 square. I mean, okay, it's basically 9,000 pascals times pi times radius square. So
yeah, because the radius is 1 centimeter, right? Not 2 centimeter. Yeah.
Yeah.
9,000 times 3.14 times 101 quadrat, right? In my calculator, I got the 2,820, 826. I just directly calculate right now.
Okay. Wait. All right. Maybe.
Yeah.
R square. Maybe I'll show you my calculator. Yeah, I'm getting this. So.
Okay, quite different, but no worries. Maybe your calculator like P is not directly 3.14, but 3.45, blah 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 until the long. So, yeah. But
okay.
already got the same?
No, it's like I'm missing 1,000, like somewhere.
Missing the 1,000? 9,000 PA, right?
Yeah,
9,000.
I
Yeah,
put in 9,000
9,000. Yes, 9,000 times 3.14 P with the 0.01 quadrat.
point oh one point. All right.
Yep.
So what's the question again? Basically we use the Bernoulli equation. The conservation of momentum to find the horizontal force required to keep the plate stationary. And there's no change in elevation, so we don't need to consider that. And we assume that the jet flow is steady and that the velocity remains the same because the water just passes, a jet with a wider diameter just passes through a hole with a smaller diameter, and the rest go along the plate in the y direction. So the only thing changes is the area of the diameter of the jets, like when it comes in, when it comes out. And that's why in this, and the density remains the same. So over here, like, we just need to consider the difference in flow rate at when it comes in and then when it comes out. That's why we get this equation for F equals to density times velocity multiplied by the flow rate out minus the flow rate in. And that's how you get, oh, I forgot, that's how you get 169 newtons in the left direction. And because it's negative and I took right direction as a positive, yeah, sorry guys for the confusion. I forgot to remove the minus sign at the last line.
Yeah.
So
Okay, thank you, Shuhao. Great job. And can you tell the other why you didn't include the pressure force here?
the pressure force?
Yeah. I think in the group, someone already stated, and just let the other student know.
I think I might be wrong, like but both of them are surrounded both of them are affected by subject to atmospheric pressure, aren't they? So should be the same. And Yep.
Cool. Thank you, Shuhao, for your great job, and thank you for group number 1. Yes, it's correct. So